Hello everyone, my name is Dakoba and welcome back to Satisfactory. Today we're going to be taking a look at a brand new design for a perfectly efficient endgame nuclear power plant. We're going to maximize the usage of uranium to turn it into uranium fuel rods, allowing us to make 630 gigawatts of power off of uranium alone. Now this design is modular and can be tiled both horizontally and vertically, as well as being separated into its component parts and built anywhere on the map or integrated with your existing factory infrastructure. Before we get started, everything we're talking about is timestamped in the description below. Let's get into it. Now each module of this plant will produce 7.5 gigawatts of power and is built on a 23 by 17 foundation platform. Each module will require 13.5 steel ingots, 20 copper ingots, 23 deuterium ingots, 27 raw quartz, 60 iron ingots, 25 sulfur, and 25 uranium. With well-tuned logistics, you can provide for 6 modules off a single train or truck station, producing 45 gigawatts of power. We're going to break each module down into 5 sections. These can be built together as we're doing here, or built as separate factories. After we go through the layout of the build, we'll show a diagram with the specific timings and tunings for each machine in the plant. This is also going to be posted in the description below. Our first section is built on a 3x10 foundation grid and requires 2 constructors and 1 manufacturer. Create 4 input lines, 1 for uranium, 1 for sulfur, 1 for deuterium ingots, and 1 for raw quartz. Send the raw quartz into a constructor to produce silica, and the deuterium ingots into a constructor to produce quickwire. Send the output of both constructors, along with your uranium and sulfur belts, into a manufacturer making the infused uranium cell alternate recipe. Our second section is built on a 4x10 grid and requires 5 constructors and a manufacturer. The section will also use 4 input lines, all bringing in iron ingots. Build 4 constructors in a row. The first will produce iron plates, the second will produce iron rods, the third will produce wire using the iron wire alternate recipe, and the last will also produce iron wire, and then feed that into another constructor producing cable. Feed the cable, wire, iron rods, and iron plates into a manufacturer crafting beacons using the default recipe. Our third section will be producing crystal oscillators. We're going to need 5 constructors, an assembler, and a manufacturer for this. We're also going to need 4 input lines. Inputs 1, 2, and 4 will take iron ingots, while input 3 will take raw quartz. Start by placing a row of 4 constructors. The first will produce iron plates, and the second will produce screws using the cast screw alternate recipe. These 2 constructors will feed into an assembler producing reinforced iron plates. The third constructor will make quartz crystals, while the fourth will make wire, feeding it into our 5th constructor producing cable. The cable, quartz crystals, and reinforced iron plates are then sent into the manufacturer for production into crystal oscillators. Our fourth and final section will be producing electromagnetic control rods. This section is built on a 6x10 grid and makes use of 4 constructors, 3 assemblers, and a manufacturer. Start by placing all 4 constructors in a row. The first will craft deuterium ingots into quickwire, and the second will craft copper ingots into copper sheets. The quickwire and copper sheets are then fed into an assembler to craft AI limiters. The third constructor will craft steel pipes out of steel ingots, while the fourth constructor will make wire out of iron ingots using the iron wire alternate recipe. The steel pipes and iron wire will then be sent into an assembler to be crafted into stators, and the stators and AI limiters will then go into the third and final assembler to make the electromagnetic control rods. Finally, place a manufacturer crafting the uranium fuel unit alternate recipe and feed the outputs of all 4 of our sections of the plant into it. For our burn ward, place 3 nuclear power plants and 9 water extractors. Connect the uranium fuel rod conveyor to the inputs of each nuclear power plant and run an output line away from the plant to allow for disposal of the plant's uranium waste. For each nuclear power plant, construct 3 water extractors and connect them to the nuclear power plant with a Mark II pipeline. Now to supply this factory, we're using a train-based logistics system that feeds a line of smart splitters. Each splitter separates out the needed ingredients to feed 1 production line within the plant. Next week, we'll be covering a logistics depot that can correctly provide for this type of plant, or more generally for any factory build with specific material need. We're also going to be producing a great deal of uranium waste. This can be converted into plutonium fuel rods for even more power generation, or for removal in an awesome sink. That's another video that's coming soon. And that's going to do it for today. Thank you guys so much for watching. I hope you found this build guide for a nuclear power plant helpful. Leave a like if you have, and subscribe if you'd like to see more. My name is Dakoba, and I hope you have an efficient day. I'll see you soon.